everyone, welcome back to the second session of Chapter 5. Now, in last session, we have go over the calculation of current price of bonds, which is a present value of all the future cash flow discounted back to now. We need to know the amount and the timing of the future cash flows, which includes both coupon and the repayment of principal. And we also need to know the discount factor we use to discount all those future cash flows. The discount of bonds or the interest rate of bonds, which is also the quality or the investment worthiness of the bond, is referred as the yield. Here we have a downwarding curve. This curve is the price yield curve, with yield being put as the x-axis. Now, we can notice that with an increase in yields, there is a decrease in terms of the bond price, bond selling price. Now, this is well understandable because the yield appears in the denominator. Here, that's the yields, right? And the price is the calculation of the ratio. So the value between these two factors would be negatively related to each other. Well, in a more straightforward way, a higher discount factor would lead to a lower present value. So that leads to a lower price. This curve, we can see, is not straight. It's not straight, it's not a linear function. And every unit change within the yield actually leads to different levels of price change here. Well, that is a point we are going to discuss further in our later sessions. Now, let's look at some of the types of bonds. We have the nominal yield, the current yield, the promised yield to maturity. Now, the promised yield to maturity is the yield that we have been using, is the yield we have been talking about since session 1. So that is the promised yield to maturity. And it is actually quite tricky. And also, we have the realized yield. The realized yield, we can use that function when we decide to sell the bonds early, meaning that we sell them before the maturity. Let's break them down one by one. Now, the nominal yield. The nominal yield is the stated interest rate of this bond, which is the coupon rate of this bond. Coupon rate is a basic characteristics of the bond, which is stated when the bond was issued. Now, the current yield is very similar to dividend yield. We know that dividend yield is calculated by using cash dividend per share divided by the current market price. Well, the current yield for the bond is we use the coupon payment, the current coupon payment, and divide that by the current market price of this bond. Notice that the current market price of this bond, remember, it is different from the price when we purchase the bond, which is P0, right? So after we bought the bond, there might be some change happen to the bond price. So the PM and P0 could be different. Well, let's look at the promised yield to maturity, which is the YTM that we have been talking about since session 1. This is computed in exactly the same way as we described in the yield model earlier. That yield model is referred as, say, we discount all the, well, that's the discount factor that leads the present value of the future cash flows equals to its current selling price. You didn't need to calculate that in our class, but just know how it can be computed. Well, to realize the promised yield to maturity, which is normally stated when the bond is issued as a reflection of the bond investment risk, if we want to realize that promised YTM, we actually need to keep two things to do simultaneously. The first thing is that we hold the bond to maturity. We do not sell them period to maturity. We hold it all the way down. And the second thing we need to do simultaneously is that we need to reinvest every coupon payments we have ever received within the holding of this bond at the rate of promised YTM. So that's other two factors we need to keep in mind when we want to realize the promised YTM. Now, there is this risk referred as reinvestment risk. For example, when we reinvest coupon, we may not find a reinvestment opportunity that offers the same level rate of return compared to the promised YTM. So if we cannot the high enough reinvestment opportunity, then our realized return will be lower than the promised return. And also, this reinvestment risk is also related to the level of coupon. If the coupon payments is large, then not being able to reinvest that large coupon payment at the rate of promised YTM would lead to a great loss. So that's two factors affect reinvestment difficulties, or let's say reinvestment risk. First is the high yield. Second is the high coupon payment. Always keep in mind that there is the delusion of this promised YTM. If we simply collect coupon payments and not doing anything else, we do not reinvest them as the promised YTM, then this is just a miss. Our realized return will be much lower if we cannot reinvest the coupon payment at the promised YTM. Now, let's talk about realized return. We say that realized return is the return we use when we sell the bond early. Now, to calculate such realized return, we need to know what build up our return or what build up of our cash inflow. Well, it is actually come from two sources. The first is the coupon payments that we have received within our holding. And the second source of cash inflow is the selling price of this bond. Because if we sell the bond early, we cannot collect the principal value. Well, the principal value is repaid at the end of the maturity. So if we sell the bond early, the only principal-like price we are gonna collect is the selling price of this bond. So what determines this selling price? Now, the future selling price of the bond is determined by the present value of all the unpaid or all the remaining coupon payments discounted back to the time we sell this bond. Pay attention, we do not discount those unpaid coupon back to time zero. We discount them back to the time we sell the bond, because we are calculating the future price, the future selling price here. And also, that's not the only thing need to be discounted. We also need to discount the principal. So, the future value of the selling price, or the selling price itself, is determined by the present value of remaining coupons and the present value of the repayment of principal at the end of maturity. But they are both discounted back to when we decide to sell the bond. Well, for example, we have the total investment term, referred as N, for our bond. Now, this is when we decide to sell the bond. And here, well, that's time zero, right? So here is our holding period. Here is our holding period. The difference between N and HP holding period is the remaining investment term that we decide not to go through. And when we discount the coupon payment within this period, we discount them back to here. So that is the end of our holding period. This is also the timing that when decide to sell our bond. And we also discount principal back to when we decide to sell the bond. Easy as that. So after we have calculated the future selling price of the bond, we can discount them back to now, right? Discount them back to time zero, and we compare PM with P0 to find a ratio indicating our realized yield. Now, we can actually using a different way. For example, we put all the coupons with our reinvestment to the end of our holding period. So we also have the selling price here, right? So we have the compounding value of the coupon that we have received with the reinvestment rate as the promised yield, and then we combine the selling price of the bond, and then that would give us the end value at the end of holding period. So we use this end value at the holding period and divide that by the price we paid to purchase this bond. So that is a future value which will be realized at the end of the holding period. Here is the price we paid at the beginning of the holding period. And then we can take a nth root, or let's say the holding period's root. And that will give us a yearly measurement and then -1. So that here, this part, is the way we can use to calculate the realized return. So remember, that's the ending value at the end of the holding period, and that's the beginning value when we pay for the bond at the beginning of the holding period. And then we adjust for the compounding factor. We take the HP's, or let's say holding period root -1. That will give us the calculation result of the realized yield. Now let's look at some of the examples. Assume we have a 5-year bond, the 1,000 per value, and the coupon rate is 6%, and the yield, or the yield to maturity, or the promised yield to maturity is 7%. However, immediately after we have already bought the bond, the YTM, the interest rate, rise to 8%, and remaining that to maturity. Now, calculate the realized return if we hold the bond to maturity. And the interest rate is paid annually, meaning that there's only one time of coupon payments within 1 year. So the investment term is a year's length. There is a change in interest rate after we bought the bond. So, what is the implication? Well, the implication is this new interest rate, even though it does not interfere our purchasing price of the bond, because when we buy the bond, the yield is still 7%. So we use that 7% to discount all the future coupon payments and repayment of principal. We use that to calculate our buying price or the purchasing price. However, when we talk about the realized return, remember, when there is a change in interest rate, it also reflects that to keep up with the change in interest rate, we also need to adjust our reinvestment rate. So that means after a change or an increase in interest rate, when we do reinvestment of our coupons, we need to reinvest our coupon at the rate of 8% to keep up with this change in interest rate. Let's calculate the purchase price first. Now, this is the function that we have talked about using the geometric proportion series to ease the calculation. We can also do this by discount the coupon payments one by one. The result will be the same. If you are interested in this function, you can test it out. That is our coupon payments per year, and that is our yearly rate. And that 5 here, which is shadowed somehow, that 5 indicates the number of investment period. The bond have 5 years to maturity, so we have 5 years as our power here, and that is the PV function of coupon payment. And the second part is the PV function when we discount principal value back to the time we purchased the bond, which is time 0. Now the calculation gives a price of $959, which is below its par value. Now we can tell that the coupon rate is 6%, which is lower than the yield to maturity of 7% when we buy the bond. So this means this is a discount bond, which will have a selling price below 1,000. Now, let's see the terminal value of cash flows at year 5. The terminal value at year 5 are actually given by 2 components. One is the reinvestment of coupon, and the other one is just receiving the last coupon and the last payment or the repayment of principal at the end of maturity. By the end of year 5, the last coupon and the repayment of 1,000 would be a present value at year 5. Remember, present value at year 5, it is still a future value, right? So the terminal value of cash flow at year 5. Here is the compounding factor of all the coupon payments. This is what we are going to have if we reinvest every coupon payments to the end of the maturity at the rate of 8%, which is the increased YTM. We need to keep in line with the change in interest rate. This compounding function looks very similar to the discount function. Here it's not the same though. We can also deduct this function from the geometric proportion theory. It is the same. All right, so just remember this is the compounding factor which calculates the future value at the end of year 5. If we continue to reinvest our every coupon payments at the rate of new promised yield to maturity, that's 8%. All right, and then we can see the terminal value of this bond comes at year 5 will be $1,352. And if we want to calculate the realized yield within this period, what we need to do is we divide this end value with the purchasing price, which is given here, and then take the 5th root because there is 5 investment term. Each is 1 year, and then minus 1. We have 7.11% realized return, which is higher than the promised yield to maturity, which is 7% when we buy the bond. Now, this actual 11% rate of return is actually given by ourselves. When we reinvest our coupon payment at the rate of 8%, we introduce this 11% extra return. However, if we cannot reinvest our coupon payment at 8%, we can only reinvest our coupon at the rate of 7%. Then this realized return, if we hold the bond to maturity, would have the rate of 7%, which is only equal to its promised YTM before an increase in interest rate. So there is that. Just pay attention that this is the future value, the compounding function of coupon, and this is the discount function of coupon. Come to the second part of this question. So if we decide to sell our bond, not hold it to the maturity, we sell it at the end of year 2. So what is our realized rate of return? Now, we need to know the selling price at the end of year 2. But that's not it. We also have 2 times of coupon payments because by the end of year 2, we have received 2 coupon payments, and there are 3 unpaid coupon payments. So there is 3 remaining years. So what we need to do is first we calculate the future price of the bond, and then we combine the future value of these 2 coupons at the end of year 2. And then we do a comparison. Now, when we calculate the future selling price of the bond, we need to calculate the present value of the unpaid dividend, and we discount them back to the end of year 2, which is when our holding period ends, which is also when we decide to sell the bond. So that's the time 0 for selling. And the real time 0 is the time 0 for buying, right? Also, we have a repayment of capital at the end of the maturity. We also need to discount that principal back to the end of year 2. So there is a 3-year gap between the maturity and the end of the holding period, which account for the power 3 here. So this part is still the PV function of all the remaining cash dividend at the end of year 2. And here is the present value of the repayment of principal at the end of year 2, which gives us the selling price of the bond at the end of year 2. But that's not it. We still have 2 coupon payments. Now, the coupon payments, actually only one of them has undergone the reinvestment process. So that is the first coupon payments, because the second payment is being paid at the time we sell the bond, or simultaneously. So the second bond does not involve any reinvestment process. Only the first coupon have gone a 1 year of reinvestment, and we need to keep up with the change in interest rate. So the reinvestment rate within our holding period is 8%, which is the changed interest rate. Now, that is the end value of the first coupon at the end of year 2. Now, that is just the second coupon, which will be paid at the end of year 2. Now, this gives us the future value of coupon at the end of year 2, combining with our selling price. So that is the price, or that is the cash flow, or the terminal value at the end of year 2. And we divide that with P0, which is the price we pay for this bond. Now, we have undergone 2 investment terms within the holding of 2 years. So we take a square root of this value minus 1, which gives to the value of about 6%. So that is the realized return if we decide to sell the bond early, yet still reinvesting our coupon at rate of the changed interest rate, even though for just 1 investment term. All right. Now, we can see that if we decide to sell the bond early, the realized return is lower, because we haven't received that many of coupon payments to build up our returns. So, easy as that. Now, we have go over some of the basic functions to calculate the price of the bond. We can use the promised yield to maturity to calculate the selling price of the bond, and we also need to calculate the future selling price of the bond if we decide to sell the bond early. All right. That's the end of this session. See you in next video. Bye-bye.